In 2012, a glass panel weighing 56 pounds fell from the 38th floor of the Millennium Tower Boston. Not the San Francisco one that sinks, a different building, a different failure, and shattered on the sidewalk below. Nobody was standing there. That is not a footnote. That is what separates this story from a different kind of story entirely. This channel covers buildings that were sold as safe, approved as safe, and turned out not to be. If that subject interests you, subscribe now. Here is how we got here. The building at 776 Boylston Street was not a budget project. When it opened in 2010, the 37-story mixed-use tower called the Prudential Tower Annex, formerly the 111 Huntington Avenue development, marketed under the name One Prudential Plaza, later rebranded as various commercial designations, was a $160 million construction anchored to Boston's Back Bay skyline. The exterior was designed as a curtain wall system, 4,700 individual glass panels, each one a structural skin element attached to the building's frame by aluminum pressure fittings and sealant joints. From street level, it looked like a single continuous surface of glass. From an engineering drawing, it was 4,700 separate attachment problems. The developer at the time, a joint venture between Copley Place Associates and a Boston-based construction group, marketed the building to commercial tenants as Class A office space. The glass exterior was not incidental to the pitch. It was the pitch. Glossy brochures from 2001 described the facade as a high-performance curtain wall system with superior thermal and acoustic properties. At full lease-up, annual rental income from the commercial floors was projected to exceed $14 million. The building sold its premium address in part on the visual promise that the glass delivered. What the brochures did not describe was the fabrication process of the glass itself. The panels installed on 111 Huntington Avenue were thermally tempered glass, a type manufactured by heating standard float glass to approximately 620 degrees Celsius and then rapidly cooling it with jets of pressurized air. The process creates a compressive stress layer on the surface that makes the glass significantly harder to break under lateral impact. When tempered glass does break, it shatters into small, relatively blunt fragments rather than the long shards produced by standard glass. This was considered a safety feature. The problem is what happens inside the glass before it breaks. Tempered glass contains nickel sulfide inclusions, microscopic particles, typically between 0.05 and 0.05 millimeters in diameter, that form when trace amounts of nickel and sulfur in the raw material combine during the heating phase. These inclusions are chemically stable at the high temperatures of tempering. At room temperature, they are not. Over months or years, nickel sulfide inclusions can undergo a phase transformation, expanding slightly as they change crystal structure. In a panel under constant surface compression, that expansion creates a stress point. The technical term is spontaneous breakage. The operational meaning is that a glass panel, installed correctly, maintained correctly, with no impact and no defect visible to inspection, can simply fracture and fall. The industry knew this. The mechanism had been documented since the 1960s. The standard mitigation, a secondary process called heat soaking, which involves holding finished panels at 290 degrees Celsius for several hours to trigger any latent inclusions before installation, existed and was commercially available. The panels on 111 Huntington Avenue were not heat-soaked. The first documented breakage on the building occurred in 2007, 5 years after the building opened. A facade inspection report commissioned by the building's management company noted isolated spontaneous failures in 3 panels on the south elevation. The report recommended monitoring. Monitoring in this context meant visual inspection at intervals. No panel was replaced immediately. The report was filed. The building continued to operate at full occupancy. By 2009, the number of documented spontaneous failures had risen to 17. A second engineering assessment, this one commissioned by the building's Commercial Association Board, concluded that the failures were consistent with nickel sulfide inclusion events and recommended a full facade audit. The audit was completed in the spring of 2010. It identified 41 panels with visible stress fractures. It could not identify how many panels contained inclusions that had not yet reached failure threshold, because that is not detectable by visual inspection. Consider what that means precisely. In the spring of 2010, there were 4,700 panels on the building. 41 of them were visibly broken. An unknown number of the remaining 4,659 contained inclusions that would produce spontaneous fracture at an unknown future date. The audit had no method to determine which panels or when. The building remained open. The broken panels were replaced. The 2012 incident changed the calculus. On a Tuesday morning in October, a panel on the 38th floor fractured and separated from its aluminum frame. The panel did not fragment cleanly into small pieces as tempered glass is theorized to do under ideal failure conditions. It broke into several large sections. One section remained partially attached. Another fell. The largest piece, later recovered by the building's management team, measured 14 inches by 22 inches and weighed 56 pounds. It landed on the brick plaza below. The plaza was empty at that moment because it was 6:47 in the morning. By that evening, the building's management had placed emergency calls to the City of Boston's Inspectional Services Department. By the following morning, city engineers had arrived on site. Within 72 hours, a decision had been reached that had no modern precedent in Boston's commercial building history. The entire curtain wall, all 4,700 panels, was to be assessed for immediate removal risk, and panels identified as high risk would be boarded over with plywood pending replacement. The plywood installation began in November 2012. Among the tenants occupying the building that fall was a technology consulting firm on the 22nd floor. The company had signed a 10-year lease in 2008 at a rate of $48 per square foot annually, a figure that reflected the building's Class A designation and premium address. When the plywood appeared on the floors above and below them, the firm's facilities director contacted building management in writing asking for an explanation and a timeline. The response, dated December 3, 2012, stated that remediation was underway and that the facade will be fully restored to its original specification. The timeline given was 18 months. By the end of 2013, approximately 800 panels had been replaced with new thermally tempered glass. The remaining approximately 3,100 original panels remained in place, with 340 of them boarded over with plywood, where inspection had identified structural concerns. The 18-month timeline passed. The plywood stayed. By the end of 2014, the remediation had replaced a total of 1,200 panels. The plywood count had risen to 380. The technology firm on the 22nd floor had, by that point, broken its lease and relocated to 100 Federal Street at a cost the company's annual report characterized as a significant and unbudgeted facilities expense. The building's published occupancy rate declined from 94% in 2011 to 71% in 2014. The question of who was responsible for the original glass selection was not simple, and each party's position deserves a fair statement before it is measured against the record. The developer's position was that the curtain wall had been designed and specified by the project's facade engineer, a specialist firm contracted to produce the external envelope design. The developer had relied on the expertise of that specialist and had no reason to independently evaluate the heat-soaking decision. That position is not unreasonable. Developers routinely rely on specialist engineers for technical specifications outside their core competency. The facade engineering firm's position was that at the time of the building's design in 1999 and 2000, heat soaking was not required by the applicable Massachusetts building code. The firm had specified a product that met all code requirements. The decision not to require heat soaking was a code decision, not an engineering error. That position is also not entirely wrong. The Massachusetts building code in effect in 2000 did not mandate heat soaking for commercial curtain wall applications. The City of Boston's position was that its Inspectional Services Department had approved the building based on code compliance and had no mechanism and no obligation under the existing framework to require additional thermal processing beyond what the code specified. Each of those positions contains something true. The record also contains the following: an internal email produced as part of a civil lawsuit filed by the building's Commercial Tenant Association in 2015 showed that a project manager at the facade engineering firm had written in March 2000 that heat soaking was advisable given the scale of the installation and had flagged the cost differential, approximately $180. 00 for the full panel set at 2,000 prices before the specification was finalized. The email's reply, sent by a senior partner at the same firm, reads, "Client has approved standard spec. Document and move on." The $180,000 decision became a $160 million buildings-defining structural liability. The new glass started failing in 2016. The replacement panels installed between 2012 and 2015, the glass meant to solve the problem, began showing spontaneous fractures at a rate that building engineers initially attributed to installation stress. By the summer of 2016, 7 replacement panels had fractured. By the end of 2016, the count was 14. A third-party materials analysis commissioned by the building's insurance carrier concluded in February 2017 that the replacement glass also contained nickel sulfide inclusions at rates consistent with the original panels. The replacement glass had also not been heat-soaked. The contractor responsible for the remediation work had specified thermally tempered glass from a different manufacturer than the original installation. The specification had not included heat soaking. The building's management had approved the specification. Nobody in the approval chain had required it. The building had spent 4 years replacing its windows. It had replaced them with the same category of product produced by the same general process, carrying the same inherent vulnerability. By the end of 2017, 200 of the replacement panels had been removed and replaced a second time. A portion of the building's south elevation was once again partially boarded over with plywood. The plywood that had first appeared in November 2012 had, in some sections, been in place for 5 years. The civil lawsuit filed in 2015 by the Tenant Association was settled in 2018. The terms were confidential. The facade engineering firm's liability insurer confirmed the settlement without disclosing the amount. The developer entity that had originally constructed the building had restructured through a corporate transaction in 2013, and the successor entity's attorneys argued successfully that liability for design decisions made by the original joint venture did not transfer. The City of Boston was not a named defendant. The Massachusetts Building Code was amended in 2019 to require heat soaking for thermally tempered glass panels used in curtain wall applications above 10 stories. The amendment applied to new construction only. It did not apply retroactively to existing buildings. The building at 111 Huntington Avenue is still standing. As of the most recent publicly available facade inspection report filed with the City of Boston in 2023, the curtain wall had been substantially replaced over the preceding decade, with approximately 4,200 of the original 4,700 panels now in their second or third generation of glass. The building's commercial occupancy had recovered to 83% by 2022, still below its 2011 peak. The technology firm that relocated from the 22nd floor in 2014 never returned. The unbudgeted relocation cost cited in their 2014 annual report was $2.3 million. No portion of that figure was recovered in the 2018 settlement because the firm was not a party to the litigation. The Massachusetts Code amendment that requires heat soaking, the one that would have prevented this, passed 19 years after the building opened and 17 years after the internal email that recommended the process was overruled for $180,000. There are curtain wall buildings in every American city. Most of them were built before the amendment. Most of them are not in Massachusetts. This channel covers those buildings.